on a R. So if you say Ctrl enter, you can see the sum. It is not found. Oh, I did not run this. Sorry. Just a moment. Let me just run this. You have. Okay. Hope you can see my screen, right?
Yes. Yeah.
Yeah. So this is just the software itself. So there's some links I had shared to your to the chat. So there are two links. The first link it will redirect you to download the R software. Let me just I think you can also reshare it, Mr. Francis. You can just reshare the link to the chat so that they may try to install the software itself. So and then you have to also install R. So you have to install R so that you can program in R, and then we'll use now the software itself, the R Studio, to do the programming. So basically, this is the interface of this is the IDE. So here is where we write the code. The top left, this is where here is where we write our code. We also have the console, the terminal, and the background jobs to our bottom left. To our top right, we have the environment, history, connections, Git, and the tutorial. So here we can also like try to connect to GitHub and also push the code. And then here to our bottom right, we have the files, plots, packages, help. So here we can see the result of what we are doing in our editor. So this is like our editor here. We can write code here. You can also write code on the terminal. It's depending on your preference. You can write code either here or here on the. You can write it on the editor itself or on the terminal, depending on what you want to do. And then you can see the results on the top, on our bottom here, on our bottom right. So we may get straight right away. So it's just R basically is just a simple it's a simple programming language, and most of it is it's used for like you can do analysis, you can do some data science, you can also build like a sort of a dashboard, your data science dashboards, to try and see to visualize some things. So it's basically it's a free and open source programming language, and it's a software environment for statistical computing. You can also do some data analysis. You can also do some graphical visualization. So it was first. I can give like a brief history of R. It was developed around 1993 by some pioneers, and since then it has been growing and being updated every now and then. So as I said, you have to first install R, so that you may now program in R, and then you also have to install R Studio. So when you install R Studio, you'll get this IDE, and you install the IDE so that you may be able to program, and you also have to install R itself so that you may program in R. So after that, when you are here, you may do some. If you want to program, here is where you program. You can just do some simple things so that you may see how it works. So you can just write some, like, let's say 1 + 1, and then you can say Ctrl enter. That's to run the code, and you can see the result here in the console. That's usually printed on the console. So when you do you may perform some doing some simple. You can also try to use these. There's a way that we can look at what. If we are stuck, we can just try to see something and see. We can be redirected to what you can just do. You can use this question mark to try and understand what you can get some information from something. So you can get some help. It will direct you to help. You can see what the arithmetic mean is about. So when you go, you can see the result here on our bottom right. You can see what something entails and how you can use that. If it's a method, you can try to incorporate that in your work. So basically, in this R Studio, one thing I like about it is that there's a like inbuilt data set which you can work with. It's not a must that you have to download some data and then you do some analysis from there. There's like a data sets within R Studio. When you download it, comes with some data sets. So I'll just take you through some brief syntax about brief R syntax, and how how you can actually program in R. So basically, there's some. I just wanted to start on objects and functions. So basically, you can like assign. Uh, there's a way you can assign variables here. Like, you have to use like the arrow operator, and then here you usually assign like let's say like A, you assign it to number 5. Let's say A is 5. So what you're doing here is like you're assigning the variable A. You're giving it the number 5. So you can also do the same to B. Uh, and then you can say that is 10. And then when we do some if we do the sum, when we say like A plus B, we'll see that the result is we can see the results for ourselves. So let's say A plus B, and then when we say enter, we can see the results. So this is just basically some R syntax so that you can first understand and understand. Let me just say enter. So you can see the result printed on the console here. A is not found. Okay, let me just try to see this. Or I could just say like sum of A and B. Let me just do this. I can just say sum. It's on a R. So if you say still enter, we can see the sum is not found. Oh, I did not run this. Sorry. Just a moment. Let me just run this. You have, and then when I do the sum of A and B, so we see the result here. You can see the result on my bottom left. So you can see the result is 15. So you have to run. That's actually something I had to mention first. When you like declare a variable here, you have to like run. You press after declaring like A, you assign 5 to A. You have to like press Ctrl enter to run that so that it may be stored as a variable, and you can actually access it from there. So basically, what you can do next is there's some ways you can actually like just do the sum the way I've just shown you, and you can also like assign and you can also assign like variables. Let's say you want to create like a data frame. You can create a data frame, and this is just the syntax. I'm just taking you through the syntax, and then we'll do some snip. We'll do some. We can work with some geospatial data and see how you can do some geospatial analysis with the geospatial data. So I want to take you like let's say we can use names, and then we assign James and John. Let's say James, John. Okay. Then we just go next. Okay. So if we want to create a data frame, we can say like then I create let's say like age. If I have to create like a data frame, I'll also have to like age. Then I have to input like a C, and then let me just do this. Hope some of you can follow along and see and try out some of these things, and you can. It's just the same way you code in Python. It's just this. It's just like an easier syntax, and if I'd want to create like another, uh, if I want to create like a friends data frame, I can just do that. So here you just call and say data.frame, and just the same thing.
Luego tiro así de tiro reiki.
I just wanted to take you through just some simple it's just some simple R syntax. So and you can see and get to understand how you can code in R. It's just simple and just like that. And when you run this, so you have to run every time. So from the first one, we have to come here and then run that line, the same to this.
Umpe au hata umpigie. Vile akilie
hata upata tumejua sasa, mtu unamtoa then unamteka. Sasa hiyo umefanya aje?
Okay. So this is just like the syntax.
Haya, hii ni simple 1 + 1 2. Poa.
amereply.
Sasa hivi tupate na hiyo hapo. Sasa ako wapi? Kuna hiyo
Pia tuko na extension haya ama
mimi niliconfigure nilikuwa naitumia hapa kwa Jupyter. Sina kumbuka akisema Julia Python na si unaweza itumia kwa Jupyter. Hata Julia unaweza itumia hapa pia.
si kufanya configuration hiyo
Yako. Google.
Just add lowercase c in line 11 before James.
Ati Jupyter. Azum unatumia kwa hivi. Pia tunampia Julia maana sasa unaweza klika hapa Julia.
Yeah. Right?
Yes, before the brackets.
Sasa nimemuuliza default one. Niambie
Okay. So
Lowercase c to concatenate.
yeah, true. So
congratulate.
you're saying line 11, right? Here. I think I just mistake
Yes.
somewhere.
After the assignment symbol, you put c then brackets.
Just a moment. Let me just see.
Hata misbehave.
Kajasikia anapungiwa. Kamido. Makosha.
Napenda hii speech.
Yeah. So I had gotten some moment.
Ndio meeting ya jida ilikuwa na watu wengi. Nani ni kwa simu? Ndio ni value 5.
Yeah, it should be age, not ages.
Oh yeah. You see some simple mistake and you're wondering where the problem is. Yeah, so that's just a simple data frame. So thank you, Mr. I did not note your name, but thank you for that. And just creating some simple data frame. See, like you just create like the names. It's the names row and the age row, and then you create just a simple data frame, and you can do some analysis from there. So it's really like you have to be like keen when writing the code, and yeah. So that was just some syntax I wanted to show you, and maybe we can just move along and just continue. So there was some code I had shared some links with you people, so you can go to the chat. Okay. So there's these links I had shared with you, so you can just follow along. There's a link I had shared. I think I can also reshare again. There's this link I think I had published on Medium. You can just follow along the codings. If you don't have the software now, you can just follow along maybe later. So we'll now just move on directly to geospatial analysis with we want to deal with the geospatial data. So what we'll do is I'll just use some okay, just a moment.
Iko kwa hiyo ni nini ni bango na venye juu inafunguka na button tatu R ili kuingia
I just used some snippets of of the code I had already written before. So there's this link that I had shared just a moment. You can also access it via the link, and you can just follow along instead of us having to write the code, and you can just follow along, and you can see how you can do some analysis with this. Just a moment, let me open the link too.
Mimi ndio nani. Niona hii ya host akitengeneza nini? Example ile ya Zoom.
Okay, so you can just follow along, and there's this object here with objects and functions. I had just talked about how we assign the variables, and you can do some pre-processing, and so first of all here I said there was some built-in data sets that we could use, such as if I just come here to, let me just go back. If I just want to see the data that is available in RStudio, you can just type that command, and it'll enter. So you can see the data that is in the data that in we have a lot of data sets within RStudio. So when you install RStudio, it comes with these all data sets. You can do some analysis with it. So you can do something like if you want to see, let's say you want to work with this. There's the sunspot, there's rivers data, there's the river data, there's MDATs. So I think this is like monthly dates of lung diseases in the UK. So with all these data sets, you can do some data science with it, and you can just get to, first of all, you can read the data, you can then explore the data, you can then do some data cleaning, you can then describe the data, and then you can also do some machine learning algorithms with the data that these data that we have within RStudio. So we might go first with wanting to first to understand our data. So we can explore, let's say, I can start with some data. Let's say one of the most popular data sets that are within this within RStudio is you can work with tidyverse. I think with tidyverse you can just install. There's a way you can install packages within RStudio. If there's no package within RStudio, you can just install it. It's just a simple command. You just say install.packages, and then you just install if it's tidyverse. If you want to work with tidyverse, you can just use that. So if you have it, for my case, I have it, but this just, you can just use this command to, the way you'd say in Python, the way you'd say pip install geopandas, or maybe pip install pandas. Here you can just say install.packages tidyverse. So basically it will just, that command will just you get to install your R package. So for me, I have it. So if you want to call that package, you can just say library. So let me just say library tidyverse. So and then it'll end. So and then so you've called the package, and then you can do now some analysis from there. So if I wanted to work with, let's say, for my case, I just wanted to work with the Star Wars data. So I think I've worked with it a lot of times, and I'm good with it. So you can just call some. So there's something I wanted to say here. There's a pipe function. What I'm going to do is you can just press Control Shift M. So it's this is just basically like you are telling it's a pipe operator. So what you're seeing here is it's a pipe operator. You can use this to say it's like saying and then. So you can say Star Wars. If you want to do some query within this Star Wars dataset, you can put in some other functions. You can put in some functions that can query some data, and you can actually display some data with that. So in this case, I just wanted to load this Star Wars dataset. So within the Star Wars dataset, we have the height. So I wanted to just create some simple function there. So this function is basically like looks at within the Star Wars dataset, the height that is above 150, and for the masses that are within less than 200. So it will basically it will query those specific datasets that you want to, and then you put again the pipe operator. So it is just the way I just told you, shift Control M. So and then enter. Again, we go to mutate. There's some functions you can just these are just some, you can go through the documentation with R, but they're just simple functions that we'll get to work with, and the methods that you can call within R package. So and then height in meters. So is equals to, let's say I want to assign like if you go to these the Star Wars dataset, you will see that let me just finish and then I'll show you what I mean. So let's say
John Dicho.
then the type operator again. Select. Link. So this is just like if you want to arrange our data set from the smallest to the largest. So basically, just show you how it really works. So we want to view our data set. So here we've just queried our, when we say view, here we want to see whatever we have done here. We want to see what we have within that data set now. So we just say ctl enter. Oh, so I think I messed here. It's supposed to be
line 25, spelling of meters.
Yeah, true. Here. Yeah, true. Thanks for that. Okay. Yeah, so when we say, let me just, you have to again run it because it will have to remember that. So you still enter the same to
spelling of meters. Yeah.
Okay, where is that?
Odero.
Trying to see. So let me just run again. Just a moment. You can just keep running. Error in select. So there was an issue here. Oh, okay. So what I can do is I can run this. Let me just run from the beginning. I have to repeat to run it.
Spelling of height after mutate.
True. Thanks for that. True. Thanks for that. I have seen it. I had, you see one mistake and you're out of. So when we run that, we can see some. We can see this was just the Star Wars dataset that we had. So if I wanted to first of all see the Star Wars dataset, I could have done this first. So I wanted to first show you what. Let me just close this first. I wanted to show you like the Star Wars before doing this pre-processing. So before doing this, I think the dataset I could just say view. Then I write Star Wars. So if I could run this before, you could see, just a moment. Then yeah, so if I run that, you could have seen before So the Star Wars dataset is like a really huge dataset. So this is the whole dataset for the Star. It's a whole dataset that has a lot of columns and rows. So you can just the code that this function that I created here. So this was the original, like the original dataset. So there's actually some missing datasets. You can see here NA. This written NA that like missing, or let's say they are null values. So uh, with that data set, before I did this it's sort of like processing, before I did this filtering, the Star Wars data set was a whole data set. So but when I input this function, I just input a function to like a query for me to only filter out where the height is. There's actually like a column within the Star Wars data set, it's called height. There's this height, and there's also the mass. So I just, this function, like it's sort of like it's you just telling like you're telling it to look at the within the data. It takes the height that's above 150 and the mass that's below 200, and you assign like a new variable, height in meters. So it will take the height, it's actually in centimeters. In the original data set, it was in centimeters. So if you want it to be in meters, you can put a function, let's say like divide by 100. So and it will convert it to centimeters. So this was what I did here, height all over 100, and you can select. Now we only remain with only those two that you've queried. You can only remain now with the height in meters and the mass. So and then you can arrange the mass from in ascending order. So there's also like if you see now, if I run this function here, you can see that we only remain with only those two, only those two columns. So you can see we have height in meters and the mass. So that's what we had queried, and the mass is arranged in ascending order from the smallest to the largest. So this arrange function, this arrange, it's a, let's say, a method. This arrange method here, it arranges the data set, your data from in ascending order. Let's say you want to see your data set from the lowest to the highest. So that's basically what I did there. And I think because of time, I can just be copying, instead of writing the code. I can just be copying from this what I had done. So and then we can see the results and see the geospatial analysis. So if I just open this,
It's about first one. It's about first one. It's about first one.
I have to close some things here. Yeah, so let me just close some things. Yeah, so you can actually do some further analysis. Those these you can use these methods. You can explore your data using these methods. They are like the glimpse. Like if you want to look what your data has, these are just some data science methods that you can use within R to look, to have like a quick, if you want to look at like an overview of your data. So you can just use this glimpse and you pass in that. If you have your data from there, you can pass in within these brackets to see an overview. So you can just do it. Just do it here, and then we see. So if you want to look like have like a glimpse of your data, let me just show that. If you have like that Star Wars, you just want to have a glimpse of your data. So basically, what you'll do is you'll use this. It's a method that you can use to have a look at your data. So just a quick look. It will give you like some summary, and you can see what's contained within your data set. So your data has like the name, height, mass, skin color. So and then yeah, so you can just see the same to the other ones that I just showed you. We have you can just look at the length of your data. Oh, it's taking some time.
Almost kumaliza hii recording. almost kumaliza hiyo recording.
Just give it a while. Yeah, so you can have like for this case I wanted to use now there's another data set. It's a mammal data set. So for this I just want to jump onto the geospatial data set that I used, but first of all I just wanted to show you can explore your data. So you can use these methods, the head, the same way you do in Python. You want to look at the first 5 rows of your column, but in this case it's the first 6 rows of your data frame. You can just use this head and see. For this case my data frame was mslip. So you can also use length to see the length within your data set. Now this is what I wanted to show you about the missing. If you want to remove, like you want to see if you have like missing data within your data frame. So you can come here. So there's also another data set called
Nasikika huko kwa meeting.
slip.
Hello?
So it's just like a data set for mammals. It's just data about mammals. So you can see that data and the same the methods that I had told you, like the length. You can just say length and look at the data set. So you can see the length, it's 11. So it has you can just see some information about that data. Yeah, so if you want to check for missing, you want to see within all the given rows if there are no like missing data whatsoever. So you can try to use that. It's that function here that I just showed you. Like this to check whether there's some missing data within that data frame. I think. Okay, let me just run this first. So you can see there's some null values actually. So you can see that there's some, this NA means like not available. So it's like a null value. So you have to do some, can also do some data cleaning. That's if you have some data set. So I just wanted to jump where we are using, to jump right away where we're using we're using Geospatial. I see time is going, it might not be on site, but you can do some data cleaning. So with data cleaning, the same way we do in Python, you'd want to remove like the null values, you'd want to drop some columns. So you can always like you want to deal with missing data. So you can remove all the you can remove like all missing data within a data frame with this function. So yeah, so you can remove this was just what I was illustrating there. So I just want to jump right ahead, and then we can also do some describing of your data. You can just like you can just say mean, there's the mean, the marks. These are just like statistics. If you want to see the statistics within your data, so you can just use these methods: interquartile range, the range, and the minimum, maximum, and you can see what's contained within your data set. So I just wanted to show you how we can start now with the geospatial data. I think I did not want to stay along with the syntax about R, but I think as of now you just understand the basic syntax, the basic R syntax, and how it works. So you can, if you're working with geospatial data, basically geospatial data is data that has location pinned within it. So it's like we have the coordinates, the XY. So you may want to actually like you want to map that data and see what it's contained. Like when we're dealing with the shape files, there's in GIS we have, I know most of you are the GIS personnel, so you understand when I say we have the vector and the raster data sets. So you may want to access that data set and load it and do some analysis with that data that you have. So one of the common data types is the shapefile. So the shapefile, like it stores the points, lines, and it's just the points, lines, and the polygons, and it has some information about places. It's in vector. It's a vector data type, and we also have raster data types. Those are the images and the satellite images and yeah. So within the shapefile, we have some extensions that think you understand about this, the DBF, the PRJ, and the .shx. So these are just like other, they come along with the shapefile to, they store, actually store some data sets. Like the shapefile contains all the latitude and longitude locations. The DBF has some, they have the, it comes with some other attributes within it. So like the projection, the PRJ has the projection information, and .shx, it has like the spatial indexing. So if we want now to, let's say we have a shapefile, we want to read the shapefile and do some plotting. So we can just take like let me just take this. No need to like write the code manually, because I know the time might be not be on our side. So if I write that, and then I have to run each. So for my case, I was using this directory. I have a shapefile within my directory. It's called within user. So if I come to local disk C users, I have that Kenya shapefile within my. If you have like any shapefile that we want to read within your directory, you can just navigate to that directory, and then uh, you take the directory and place it within. If you want this, it's a method that uh, you want to set the working directory. So you have to input now where are you working from. So for my case, I was working within this directory user, and I was reading this shapefile. So, and I was using this package known as SF. So if you don't have it, I know you have to install it, and so SF, and then you install it. For my case, I have it. That's why I've commented it out. When you see this, it's a hash before the code. It's just commenting out. But so that if you have it, you'll have to install it. If you don't have it, you'll have to install it. So when you have to now, after that, you run the code, and then you have to install that package. Then you call it, and then you read this shapefile here. You read the shapefile. Okay, there's someone. Okay, so after reading the shapefile, you want to see. So it just read the shapefile, and you want to check the structure. So and then you want to actually view and see what's contained in it. And then you can also plot it. When you then you say plot, so you can see first of all what's contained within that shapefile. It can also be a shapefile. The way you would use GeoPandas to read a shapefile within Jupyter Notebook, or when you are coding in Python, you can just see the what's contained within that shapefile. As in this case, we have like, I was just reading the Kenya shapefile, and we have counties within it. So in this case, there's Marsabit, Wajir, all the counties, all the 47 counties, and they have like the unique IDs within attached to it, and the geometry column, because it's a shapefile, it must have this geometry column. It stores the like the location information of the X, Y, and the coordinates within it. So if I wanted to plot these counties, I'd just run this code, this plot into bracket counties. So when I do that, it'll just run. And when I come to the plots here, I'll just wait for a moment. It will plot for me. Yeah, so you can see. So it's plotted. And one thing I like about R is that you can actually adjust what you have there. You can actually adjust it to what you want to see. So, and I like the visualization in R, the analysis. It's actually more, you can do something nice with R, and so that's the result of plotting the shapefiles. So you can also, like, let's say we want like a specific county within, let's say we want to focus, we have a case that we want to do some analysis with one county. So what you can do is you can do some analysis with one county. You can just subset the way you go to ArcMap and do some you can use the query builder to query for some specific county. Here you can just like do you can subset, like you can do a subset like really quickly with this with the code. First of all, I said you can first of all adjust the color. So let's try to do that. You can adjust the color for the, if you want to adjust this color, You can just use that.
Case ndio hivi.
I would have typed the code manually, but I had already done it. But you can just, if you even you from your side, you can just try to run and see. You can adjust anything you can put. For my case, I wanted it to be blue and the outline to be black, so you can just adjust and see with what the colors that you want. So, and the next thing was I wanted now to subset. Let's say you want to focus with one county, you can subset that data. Let's say I want to focus with only Nyeri County. Let's say Nyeri County, and then I'll have to assign it to. I'll have to use that counties. It's like you have to sort of, there's some operators that you have to use in R. You can access this operator here. It's like a dollar symbol, but it enables you to access you can access attributes within your data frame. So I have within my data frame, I have some attribute called county name. So this county name is like this. I think I had shown you here. If I could go here, ahead here, just a moment. So if I would go here at counties, there's this column. It's there's this column called county name. So it has all the counties, but this is what you can use to query and subset data within our data frame. So I'll just copy it like that, and then name, and then you can use that operator to pick out specifically what you want. So for my case, I wanted Nyeri. I just wanted to look at Nyeri and see how, just to see some analysis. So you have to like assign like that, and then so if I want to plot out now, I can just plot out my Nyeri County. So you don't want to mess there. I've been sure your market. The operator here, I have to use like it's supposed to be 2 equal signs. So, that. Then I plot out Nyeri. So I wanted to focus only with Nyeri. Then I can now do some further analysis. So for Nyeri County, the way you would use some, actually the goodness with R, you can integrate it with Google Earth Engine. I know most of you have interacted with Google Earth Engine, and you've done some analysis with geospatial analysis with Google Earth Engine. The way you'd go to Google Earth Engine and fetch some data sets and do some analysis. Let's say, let me just look for another tab. Let me say I want to do some analysis of, if I have some data sets for Nyeri County, let's say I want the rainfall. The way you would just go and look for the data sets within Nyeri County. So let's say you want to look for the rainfall. You can take the rainfall here, and then you go and overlay it on. You can overlay on the data and then see together with other analysis. You can, let me just show you just a moment.
We had a very nice.
Okay, let's say we have some rainfall data set. So let's say you had queried some data sets within Google Earth Engine. There's actually, as I had said, the way you can do analysis in Python, the same way you can do it in R. So there's actually like a Python package you can interact with Google Earth Engine. There's a Python package called Gmap. The way you can interact with Gmap and do some analysis in Python, the same way you can do it in RG. There's a package known as RGE. So
Jupiter.
let me just use Nyeri County
Rudo.
for that sake, and just to show you what I'm talking about. So let me just take this ID. So if you want, let's say you have like the rainfall data set for the whole of Nyeri. So let me just close this. So you can use that. You can access the way you can access this. Let me just show. The way you can access like the rainfall data set. So this is, I was using the chaps. So the chaps is just like another data set for you can access precipitation data set. So for this case it was for Nyeri County alone. So if you can also export it, you can export it as a CSV file, and you can also like use now the data that you've just fetched here. You can go and do some further analysis in R together with alongside with other data sets. So when I run some, I can just export that as a CSV, the rainfall data set, and then I go and overlay onto my R with a map and do some further analysis. So I think I downloaded it, so you can see the rainfall. So with this like a CSV file, you can go back to R, and then you can like try to do some overlaying with the shapefile and together with other data sets. Let's say you wanted to do some case study, depending on the case study that you want. So maybe you are doing some other project. Let's say you wanted to do some you are doing just a geospatial project, and you can access all the data sets. You can overlay them all together in R, and then you can do some analysis based on that. So so after that you come back. I just wanted to illustrate on that, and then we come here. Where are we? Yeah. So you can access that data and you can try to overlay it on your map. So I think so with that you can do some spatial autocorrelation of those data sets. Let's say you have, depending on the data that you have, I think you can organize for another session that I'll take you through how you can do the spatial autocorrelation. If you have like several data layers, you can do like the autocorrelation and see how they're relating, and you can use some functions and yeah. So I just wanted for that I was using some local data that was just displaying. It was just some simple visualization. I just wanted to show you how you can do some access. You can read the data and then visualize it. So you can go ahead and overlay some data sets here, and so what I just wanted to show you was if you're working, let's say, with global data, and I wanted to illustrate like a simple example. Since this was just the introduction, I just wanted to show you maybe how you can use this SF package in the ggplot. So we'll use that. You have to run every line. You have to run every. So for my case, if you don't have these packages, you'll have to install them like manually again. So, and you remember the way we were installing, we were saying install. Those people that maybe haven't like remembered, so you can just install like if it's ggplot, you can. For my case, I'm commenting it out because I already have it, but you can install it for your case. You just input the bracket and then you just do that. So and then you run it. You just click Ctrl Enter, or there's also like a run button there, so you can use either. So for my case, I already have these packages. I can just do some querying. Let me just, instead of typing, let me just copy and paste there, and just go again there. Then you run, still enter. So you can see what is contained within this data. So I was using this natural earth and the ggplot. The ggplot was for plotting, and this for SF is just, I think it's simple features. It's called simple features in full, but you can access spatial data sets and do some spatial analysis with it. So this natural earth, I was accessing now these data sets and then just trying to plot out. So in this case, I just accessed it, and then if I wanted to plot it out, you can see, let me just use this line of code here. I just plot it out there and see how it is plotted. So it was just some simple. I just wanted for today. I just wanted to show you how to load the data, and some simple syntax about R. and how to do some analysis. I haven't done like actually today some analysis, but I just wanted to introduce you to the syntax, and then how you can read and load the data, and then do some visualization. So maybe if I get sometime later, I'll try to show you how you can now go to deep into doing some analysis, how you can do something like spatial autocorrelation, how you can also develop like your own applications, like not necessarily an application but a dashboard. You can create like a dashboard. You can create our shiny apps. The way you can create a simple applications with Python using Django or Django. You can also create some, but for in this case, it's like a dashboard. You can create your own shiny apps. So you can, let's say you want to automate some things. So you want to automate loading a map and some spatial features such as some geoprocessing. So you wanted to maybe fetch satellite imagery. So one thing I can recommend is using something like RGE. There's a package known as RGE. So with that RGE, you can access Google Earth Engine assets. You can do some geospatial processing, and then you can further create buttons and a user interface using now the Arshiny package to do some. I mean,